Okay, so the second topic here on our properties of quadrilaterals, 5.5 day 1, we are going to get deeper into those, all of the properties of those different types of quadrilaterals that we talked about yesterday. So yesterday we just got the basic idea, right? What are the basics of all of those different types of quadrilaterals? So today we're going to get into all the details. What is every single thing that we know about each one of those different types of quadrilaterals that we learned about yesterday? So it'll be a lot to write down, so pause whenever you need to. Make sure that you're keeping track of everything. And then, make sure that you have complete notes after the end of this one, because we're going to use this a lot. So the first thing that we talked about yesterday was just our basic, right? Our regular old quadrilateral. So it's a polygon that has 4 sides. That was our definition from yesterday. So any polygon that has 4 sides is called a quadrilateral. New thing here, as something that we know about all quadrilaterals, is that the sum of the angles is 360 degrees. And that is true of all quadrilaterals. So all of these different types of shapes that we talked about yesterday and that we're going to talk about today, they're all quadrilaterals. So they all have all of these properties, right? So we know that the angles of a quadrilateral always add up to 360, and a quad always has 4 sides. All right, so yesterday I think we went in a little bit of a different order, but kite is another one that's kind of off by itself, right? It's kind of one of those funky different types of shapes. So we're going to do kite next. So we talked about yesterday, the basic idea of a kite is that it has these 2 disjoint pairs of consecutive sides congruent. And again, that word disjoint is something that not everybody is really familiar with. So again, from yesterday, this means separate and specific. So what I would recommend is, like I have a picture up here, and then we have all the lists. So make sure that you are drawing the picture and marking the picture as well as writing the list. Sorry about that. All right, so as we go through this, I'm going to mark the picture. I highly recommend that you do the same in your notes. So again, 2 separate and specific pairs of consecutive sides congruent means I say, okay, well, these 2 sides are congruent. Notice one right after the other, that's consecutive, and then probably these 2 sides are congruent, right? So it's 2 specific pairs of sides, and the same side isn't involved in both pairs. That's what disjoint means. All right. The next thing that we know for sure about a kite is that the diagonals are perpendicular. Now, as we go through all of these different things, I'm just going to give you the list of all the things that we know for sure. But we could write a 2-column proof just based off of the most basic idea of what a kite is, that it's 2 disjoint consecutive sides congruent. I could write a proof and prove that the diagonals are perpendicular. And I could prove every single one of these, but that would take forever. I will show you how to do it in tomorrow's lesson, just so you have an idea of what I'm talking about. But all of these things can be proven. All right, so the diagonals are perpendicular. So I have right angles all the way around here for where my diagonals intersect each other. For a kite, the diagonals are always perpendicular. Number 3 says the diagonal is that one diagonal is the perpendicular bisector of the other. So we know they're perpendicular no matter what, but you'll notice that one of these diagonals is bisected, right? That one is split in half. The other one is definitely not split in half. It's not being bisected. So only one of these diagonals is bisected. They're always perpendicular no matter what. The next one, number 4, says that one of the diagonals bisects a pair of opposite angles. So by opposite angles, we really mean the opposite angles of the original kite. So I can see here that this original angle BAD is split exactly in half by that diagonal. And same thing up here. So that one diagonal, AC, is bisecting that pair of opposite angles of the kite, so BAD and BCD. And then the last one, number 5, one pair of opposite angles are congruent. So again, that's from the original kite. So if you look at, like our original angles, you can see angle A or BAD is not the same as BCD, right? BAD is acute, BCD is obtuse. But the other angles here, ABC and ADC, those two angles are congruent. So one pair of opposite angles are congruent. The other pair of opposite angles are bisected by the diagonal. So there's a lot going on here for a kite. And you'll kind of see, though, how they kind of build on each other. So again, one pair of opposite angles congruent. One diagonal bisects opposite angles. One diagonal is the perpendicular bisector of the other. All right, and that's all in addition to that main thing that we learned yesterday, which is the two disjoint pairs of consecutive sides congruent. All right, now here comes the biggies, right? Here comes the parallelogram. This one is one that we use all the time. The parallelogram is the most commonly used quadrilateral out there, all right? So because of this, we do have a symbol. The symbol for parallelogram looks like a parallelogram. This is the only quadrilateral that has a symbol. Okay, there is no symbol for rhombus. There is no symbol for rectangle. There's no symbol for square, because when you write all of these other, it would be very hard to tell which one is which, right? Is it supposed to be slanted? Is it not? And parallelograms are used so much that we have a symbol for parallelogram, but nothing else. Everything else you need to make sure you write the name of. Parallelogram, you can use the symbol. All right, so yesterday we talked about a parallelogram. The main things that we know for sure is that the opposite sides are parallel, right? So top is parallel to the bottom, left is parallel to the right. And we also know that both pairs of opposite sides are congruent. So top is congruent to the bottom, left is congruent to the right. However, because of all of this, right, when I have parallel lines, then I have these transversals, right? I have all this other stuff that's going on. So the next new thing that we have is that the opposite angles are congruent. So angle B is congruent to angle D. Angle A is congruent to angle C. Okay, so the opposite angles are congruent. The next one says the diagonals bisect each other. Now, I don't have the diagonals drawn into this picture to start with, but I'm going to draw them in now. And these diagonals bisect each other, meaning both diagonals are bisected. So they're always split exactly in half. And again, we could go through whole proofs of these, you know, using our congruent sides and all of that. And I promise I'll show you some tomorrow, but for right now, there's just too many to all do in this one class period. The last one says any pair of consecutive angles are supplementary. So that means like big angle D here is supplementary to angle A. So those original two angles would be supplementary. But so would be angle A and angle B. Those guys are supplementary. Same thing here, right? So if you pick any angle, if you go with the angle before it or after it, it will be supplementary no matter what. A lot of cool stuff going on in a parallelogram. Now, if you remember yesterday when we were writing down definitions, so when I got to rhombus, I said that it was a parallelogram that had all sides congruent. So a rhombus is a parallelogram, which means that all those parallelogram properties are true of a rhombus as well. So this means opposite sides congruent and parallel. So all of those things that we just marked for our parallelogram, I could mark the same things for a rhombus. It means the opposite angles are congruent. Right? It means that the diagonals bisect each other. All of that stuff comes into play. All right, so let's see. I have to get my diagonals in here. They're bisected. Whoops. All right. So now in addition to that, we know that all the sides of a rhombus are congruent. That was our main one, right? Just like the opposite sides parallel and congruent for parallelogram, the main one for a rhombus is that all the sides were congruent. So in fact, I have all 4 of these marked congruent. So parallelogram, opposite sides are congruent. In a rhombus, all of them are congruent, right? In a rhombus, the diagonals bisect the angles. So all of these are split into 2 congruent parts. Both sides, right? So both diagonals bisect the opposite angles. And the diagonals are perpendicular bisectors of each other, meaning that the diagonals are also perpendicular in a rhombus, right? We already knew they were bisected from our parallelogram, but now I know that they're perpendicular because of a rhombus. Hey, maybe some of these are also sounding familiar to ones we've done before. The kite here, right? In a kite, one diagonal is a perpendicular bisector of the other. In a rhombus, both diagonals are the perpendicular bisectors. In a kite, one diagonal bisects the opposite angles. In a rhombus, both diagonals bisect the opposite angles. In a kite, 2 disjoint pairs of consecutive sides are congruent. In a rhombus, all consecutive sides are congruent. So a rhombus is also a kite. It just has more going on than a kite, right? So a kite only has one set of each of these things. A rhombus has both. All right, now we have rectangles. So again, all the properties of a parallelogram from yesterday, we said that, that a rectangle is a parallelogram that has all right angles. So a parallelogram would mean opposite sides parallel, it means opposite sides are congruent. Right? It means diagonals bisect each other. All that good stuff. All right. And then the defining factor for our rectangle is that all of the angles are right angles, right? So all of these angles are right angles in the corners. That was the big idea of what a rectangle is all about. The other additional thing, though, is that the diagonals are congruent. So we know the diagonals are bisected, but we also know that the diagonals are congruent. So that means that while they're split into 2 congruent parts, yes, but all those parts are congruent. So the whole things are congruent as well, right? Whole big thing. So they're bisected, but they're also congruent. All right. Then we have the square. Now, when we did our definition yesterday, we said a square is a parallelogram that's both a rectangle and a rhombus, right? So it's all of those things. It's all the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus, right? So all of those things. So I have opposite sides parallel, opposite sides congruent, right? More than the opposite sides congruent, though. If it's a rhombus, all sides are congruent, right? Okay. I have that the diagonals are bisected. But again, because it's a rectangle, I also know that the diagonals are congruent. So I've got that, right? Because I know it's a rectangle, I know that all angles are right angles. So all the corners here are right angles. Because I know it's a rhombus, I know that the diagonals are perpendicular bisectors of each other, right? So the diagonals are perpendicular. Since I already know they're bisected from the parallelogram, I also know that they're perpendicular because it was a rhombus. Let's see. Oh, and the diagonals bisect the angles because that was part of a rhombus as well. So I need one more thing from rhombus. Diagonals bisect the angles. So all of these are cut exactly in half. So in addition to them being 90-degree angles, they're also bisected, right? So while the list for square looks really short, it is in fact very huge. All the things that you know about a square is just, it's so many things, but it's all confined to, well, because it's all the things of a rectangle and all the things of a rhombus and all the things of a parallelogram. It adds up to a lot of things. All right, then the last ones we have here are trapezoid and isosceles trapezoid. So again, yesterday we talked about a basic trapezoid. The only thing we know about a trapezoid is that one pair of opposite sides are parallel, and these are called the bases, right? So this is a base, and this is a base. And there's only one pair, right? If it was both pairs of opposite sides are parallel, that would be a parallelogram. So it can only be one pair of opposite sides parallel. We call those sides the bases. Then if I want to make a trapezoid an isosceles trapezoid, so it has to be a trapezoid, right? So all properties of a trapezoid, meaning only one, which is bases, are parallel. Okay, and then it says the legs are congruent. Now this was yesterday, right? This was our defining factor of an isosceles trapezoid. And again, the legs are the non-parallel sides. So the legs are congruent. Ooh, I apologize. I do not have the right pictures here. And I just noticed it. I'm sorry. So our pictures should be switched. So this one is the isosceles trapezoid. And this one is just a plain old trapezoid. Sorry. Okay. So in the isosceles trapezoid, hopefully you can switch your pictures easier than I can. I apologize. The legs are the non-parallel sides. Those ones are congruent. Okay, so I have my bases parallel here. Okay, the lower base angles are congruent. This is also true in an isosceles trapezoid. So the lower base angles are the two angles that are attached to that lower base, right? Those two angles are congruent. We also know that the upper base angles are congruent. So these two angles that are attached to the upper base, those ones are congruent. We also know that our diagonals are congruent. So if I draw those in, the diagonals are congruent in an isosceles trapezoid as well. So those guys. And any lower base angle is supplementary to any upper base angle, and that comes from our parallel lines, right? When we have that one pair of parallel lines, these guys are same side interior angles, so the upper base angle is supplementary to the lower base angle. All right, so those are all the properties of all of those different shapes that we learned yesterday. It is a lot, and it is a little bit tricky to keep track of it all. So having a list and really looking through them a lot is one way, but there is another way, and that is to use what I call the quadrilateral family tree. So hopefully you've kind of seen a family tree before, right? So the quadrilateral is up on top. Anything that connects to it has all the properties of a quadrilateral plus some new ones, right? So everything that we've learned is a quadrilateral. Then underneath the quadrilateral, we have these three big headings, right? The parallelogram is a quadrilateral with some special things going on. The kite also has some special things, and a trapezoid. Underneath parallelogram, I have a rectangle. A rectangle is a parallelogram, so it's directly connected underneath. A rhombus is a parallelogram, so it's directly connected underneath. But as we found by looking at the properties, that a rhombus also has all the properties of a kite plus some new ones, so it's also connected to the kite family tree, right? So that's kind of what all these mean, is whenever you have that connection underneath, it means that it has all the properties of the things above it plus some new ones. The square has all the properties of a rectangle and all the properties of a rhombus, so it's connected to both. Our trapezoid doesn't have any of the same properties as a parallelogram or a kite, so our trapezoid is all by itself, but an isosceles trapezoid is directly connected to a trapezoid because it has all of those properties plus some new ones. So this idea of the family tree can really help you organize and remember, you know, like what properties are what, and so then you can just really remember what are the properties of a parallelogram. Okay, well, I know a rectangle is a parallelogram, so it has all those, plus a rectangle has diagonals that are congruent and all right angles. And then you can kind of shorten that list a little bit. The quadrilateral family tree is also a great way to answer some of these always, sometimes, never questions, which I know you guys love. So always, sometimes, or never, a square is a kite. So when we use that quadrilateral family tree to answer an always, sometimes, never question, you kind of look, where's the first one compared to the second one? If the first one is under and connected, it would be always. If the first one is above and connected, it would be sometimes. And if the two are not connected, then it would be never. So a square is a kite. Here's a square. Here's a kite, right? A square is always a kite because a square has all the properties of a kite plus more, right? But no matter what, it has every property that a kite has, so a square is always a kite. The next one says a parallelogram is a rectangle. Here's parallelogram, here's rectangle, right? Parallelogram is above the rectangle. Some parallelograms are not rectangles. Some of them are plain old parallelograms. Some parallelograms are rectangles. They have all those properties of a parallelogram plus some extras that all the right angles are right angles and their diagonals are congruent, right? So sometimes a parallelogram is a rectangle. All right. Let's see. The next one said a trapezoid is a parallelogram. Those ones are not connected at all. I mean, they're both quadrilaterals, but that's it. Their branches don't connect, so this is a never. Hopefully you're getting the idea of how to do that, right? So the last one then, see if you can do it. A rectangle is a square. So rectangle is above but connected, so a rectangle is sometimes a square, right? Some rectangles are just rectangles, but some rectangles are really special and have those extra properties of a square as well, and so then sometimes they're a square. So that's how you can use that family tree, not only to remember the properties, but also to use that to answer those always, sometimes, never questions. All right, another way that we might see using those properties, besides our proofs and our algebra problems and all that, is if we're just given diagrams that are marked up, can we tell what shapes we have, right? So if I look at this first one in the top left, what I'm noticing here is that all angles are right angles. So I think, what shape has all angles right angles? Oh, that would be a rectangle, right? That's a property of a rectangle. And then I notice that all sides are congruent. What shape has all sides congruent? That's a rhombus. And if I have a shape that's both a rectangle and a rhombus, then it has to be a square, right? Or if you think, okay, which shapes have all right angles and all sides congruent, it's got to be a square. Okay, you could go either way, all right? Okay, let's see. Let's go into the middle here. I'm noticing in the middle that I have one pair of opposite sides parallel. That's where those arrows are, right? That's these arrows. And I'm noticing that the other pair, non-parallel sides, are congruent. That would be an isosceles trapezoid. So one pair of parallel sides would be a trapezoid. The other pair of sides being congruent would make it an isosceles trapezoid. All right, so what I'm seeing here, let's see, on the next one in the far right, top right, I have all right angles. Right? I also see that I have both pairs of opposite sides congruent, right? Ooh, both pairs of opposite sides congruent would be a parallelogram, but a parallelogram that has all right angles, that would be a rectangle. All right, hopefully you're getting the idea. If you want to take a shot at the bottom ones now, go for it. All right, let's see. I see on this bottom one, two disjoint pairs of consecutive sides congruent, right? Two disjoint pairs of sides congruent. That's gotta be a kite. What do I see in the middle here? Both pairs of opposite sides parallel. Both pairs of opposite sides parallel. That is a parallelogram. All right, and then my last one, the only thing I see here is that all sides are congruent. So if all sides are congruent, that must be a rhombus. Okay. And we'll get into more detailed ones like this, but that was kind of the basic idea, right? Just knowing your properties really well so that you can name what kind of shapes you have based off of a property or two, or know what those properties are if you're given a name. All right, that was a lot to take in. I know you can do it. Remember, we have 2 days, so we'll be doing more of this tomorrow.